You know, for almost 2,000 years, we humans were pretty sure we were at the center of everything. But there was this one simple, nagging little puzzle in the night sky, and it was about to unravel that entire worldview. So today we're going to dive into the incredible story of how we finally solved the mystery of the wandering stars.
So here's the question at the heart of it all. See, from our point of view here on Earth, the planets usually just drift eastward across the night sky. But then, every so often, they do something weird. They seem to stop, go backward for a few weeks, and then start moving forward again. It's this strange backward dance that drove some of history's greatest minds absolutely crazy trying to figure it out.
Okay, so to understand how we finally cracked this puzzle, we have to go back, way, way back, to a time when the sky was basically humanity's first and most important book. I mean, ancient cultures all over the world, from Central Africa to the Americas, they were brilliant astronomers. Seriously, they used the sky for everything. The predictable movements of the sun, the moon, the stars, that's how you predicted seasons for farming, how you navigated across huge oceans. Heck, it's even how they organized their time. You know the 7 days of the week? They're named for the 7 objects they could see that seemed to wander: the sun, the moon, and the 5 planets you can see without a telescope.
And this is what they saw. Just look at Mars, for example. Over about 10 weeks, it would do this weird little loop-de-loop in the sky. It's no wonder they called these things planets. That comes from a Greek word meaning wanderers, and it's because they were the rule breakers. You know, all the other stars were fixed in place, but these guys, these wanderers, they seem to have a mind of their own. And the big question was just, why?
Well, the ancient Greeks were really the first to step up and try to create a rational, physical model of the universe to explain all this, moving beyond just myths and stories. And their solution? It was elegant, it was logical, and it was so convincing it stuck around for 1,500 years.
Their whole model was built on a few ideas that, back then, seemed like total common sense. First off, the Earth feels like it's standing still, right? So obviously, it must be the unmoving center of everything. Second, the heavens, well, that's the realm of the gods, so it has to be perfect. And what's the most perfect shape you can think of? A circle. So it just followed that everything up there must move in perfect circles.
Okay, but there's a problem. Simple, perfect circles don't explain that weird backward motion. So an astronomer named Ptolemy came up with this really ingenious fix. He imagined that a planet didn't just go in a big circle around the Earth. No, it moved on its own little circle. He called it an epicycle, and that little circle was the thing moving along the bigger circle. So the planet was literally doing a little backward loop at certain points. It was super complicated for sure, but hey, it worked well enough to become the standard model for centuries.
And for 1,500 years, that was the universe. That was the accepted truth. But then, fast forward to the 16th century, and a Polish astronomer named Nicolaus Copernicus comes along with a totally radical and way, way simpler idea. And here's where things get really interesting. Copernicus's big idea? Just put the sun in the center. That's it. And suddenly, that whole backward motion thing isn't even real anymore. It's just an illusion, a trick of perspective. It only happens when we, on a faster-moving Earth, overtake a slower-moving outer planet like Mars. Think about it. It's just like when you're on the highway and you pass a slower car. For a second, that car looks like it's going backward, relative to you. Same idea, so much simpler. But here's the catch. Even though his idea was revolutionary, his model's actual predictions, they weren't any more accurate than Ptolemy's old, complicated one. And why? Well, it's because Copernicus was still stuck on one of those old Greek ideas. He just couldn't let go of the belief that the heavens had to be perfect, which meant the planets had to be moving in perfect circles. So, Copernicus had planted the seed of a revolution, but for it to really take off, it needed 3 more things: way better data, some new rules for how planets move, and stone-cold proof. And this is where 3 new heroes enter our story. First up is Tycho Brahe. This guy was a Danish nobleman who was just obsessed with data. And remember, this is all before telescopes. He built this huge observatory and spent decades just meticulously mapping out where the planets were, night after night, with incredible accuracy. The crazy part? He was personally a believer in the old Earth-centered model, but he was unknowingly collecting the very data that would tear it all down. So after Tycho died, his brilliant assistant, Johannes Kepler, inherited this absolute treasure trove of data. He spent years trying to make Tycho's observations of Mars fit a perfect circular orbit. But he couldn't. He was always off by this tiny, frustrating amount, 8 minutes of arc. Now that sounds like nothing, but to put it in perspective, it's a sliver of the sky about as wide as a pencil lead held at arm's length. Tiny, but it just wouldn't go away. And this quote from Kepler, It's just perfect. It gets to the very heart of what science is. I mean, he could have just ignored it, right? Swept it under the rug, fudged the numbers. But he respected Tycho's data too much. He trusted the hard evidence over a 2,000-year-old idea. And that tiny little error, that's what forced him to throw out the idea of perfect circles and search for the real answer.
And here it is, the big breakthrough. After years of just brutal, mind-numbing calculations, Kepler figured it out. Mars's orbit wasn't a circle at all. It was an ellipse, like a slightly squashed circle. And the sun wasn't even at the center. It was off to the side at one of two focus points. Just like that, the 2,000-year reign of perfect circles was over.
And he kept going. His second law tackled the speed of the planets. Turns out, they don't move at one steady speed. Nope, they actually speed up when they get closer to the sun in their orbit, and then slow right down as they get farther away. And then his third law. This was the real masterstroke. He found this beautiful, simple mathematical relationship that connects how far a planet is from the sun with how long it takes to go around. It proved that the solar system wasn't just a jumble of stuff. It was an elegant machine running on precise, predictable mathematical laws. So Kepler had cracked the code. He had the math down cold. But, math is abstract. To really, truly convince people, they needed to see it. They needed proof they could look at with their own two eyes. And that's where our final hero, Galileo Galilei, and his brand new invention, the telescope, entered the story.
As soon as Galileo pointed his telescope to the sky, he just started blowing up the old Greek ideas, one by one. First thing, the heavens are not perfect, not even close. The sun, the supposedly flawless orb, had dark spots on it. And the moon? It wasn't a perfect smooth sphere. It had mountains and craters and valleys, just like our own Earth. But his next discovery was an even bigger deal for the old model. He spotted 4 tiny little dots of light, and he realized they were circling Jupiter. Moons. This was absolute proof that not everything in the universe revolved around the Earth. And then he delivered the final knockout blow. Galileo saw that Venus goes through a full set of phases, just like our moon does. A full Venus, a crescent Venus, all of it. And this is something that could only happen if Venus was orbiting the sun. In Ptolemy's old Earth-centered model, it was just plain impossible. The game was over. The visual proof was right there for anyone to see. So, this incredible 2,000-year saga, it's more than just a cool history lesson. It's really the perfect example of how science, the process of science, actually works. Because science isn't just a collection of facts, right? It's a way of thinking. First, it always looks for natural causes, not supernatural ones. Second, it creates models to try and explain what we see, like the Earth-centered model versus the sun-centered one. And third, and this is the most important part, a scientific model has to make predictions that you can actually go out and test. And if those predictions don't match reality, the model has to change, or you have to throw it out completely, no matter how much you love it. And that right there is the fundamental difference between a science like astronomy and something that isn't science like astrology. Astronomy makes testable predictions. Kepler's laws are a perfect example. You can check the math, and it works. But when you scientifically test the predictions of astrology, they're no more accurate than just guessing. One is trying to understand how the universe actually works, and the other is looking for hidden influences on our lives.
So that leaves us with a pretty powerful thought, doesn't it? It took one tiny little discrepancy, those 8 minutes of arc, to bring down 2,000 years of common sense about perfect circles. So it really makes you wonder, what widely held belief that we all take for granted today, what perfect circle is just waiting for its own 8 minutes of arc to show up and point us toward a totally new revolution in how we see the universe?